Hi, question number 3. A particle P moves along a straight line for 100 seconds. It starts at a point O, and at time t seconds after leaving O, the velocity of P is v meters per second, where v is equal to 0.04 t to the cube minus 0.006 t to the square plus 0.288 t. Find the values of t at which the acceleration of p is 0. Also, for the second part, find the displacement of p from O when t is equal to 100. Now, for a question like this, we're going to have to differentiate the velocity in order to get the acceleration and equate it to 0. Alright, so dv by dt is equal to 3 times this whole thing here, sorry, 0.0. If you multiply it, it's going to become 0.012 t to the square minus 0.012 t plus 0.288, and then t to the power 0 is 1. So now we're going to equate that to 0. So 0.00012 t square minus 0.012 t plus 0.288 is equal to 0. Using the quadratic formula, we can solve this equation. So we're going to say t is equal to 0.012 plus or minus the root of b square, which is minus 0.012 to the square, minus 4 times a, 0.00012 times c, 0.288, divided by 2a, 2 times 0.00012, 0.00012 plus or minus root of. Okay, if you work this out in your calculator, you're going to end up with 0.0000576, all divided by 0.00024. Okay, so the square root of that, let's do it on the calculator now. So we have 0.012, okay, plus the square root of 0.2345576. It's going to give us this much, divided by 0.00024. t is equal to 60. So the first value of t is going to be 60. The other value of t is 0.012 minus this whole thing here is going to give you t is equal to 40. So here are the values of t when the acceleration is equal to 0. For the second part, we need to find the displacement. What is displacement? S is the displacement, which is the integral of v dt. So integral of the equation 0.000, quite a lot of zeros here, 4t to the cube minus all this here, t to the square, plus 0.288 t. If you were to integrate this, you're going to add 1 to the power and divide this by the new power. This is going to become 4, and all of that divided by 4 is going to give you this much, then t power 4. Alright, minus, then this is going to become 3, and you divide this by 3, you're going to end up with 0.002 t to the cube, plus, and if you were to add 1 to the power here, it's going to become 2, and all of that divided by 2, 0.144 t squared, plus k, the constant. So now we know that the particle starts at rest. So when t is equal to 0, the displacement also is 0, leading to k is equal to 0. So the equation that we have is then s is equal to 0. All of that t to the power 4 minus 0.002 t cube plus 0.144 t squared. Now where do we go from here? We are told to find the displacement when t is equal to 100. So when t is equal to 100, s is going to be 0. All of that t to the power 100 to the power 4 minus 0.0021 100 to the cube plus 0.144 squared. So S is going to be then, so let's do it right, 0.12341 times 100 to the power of 4, 1000. So it's got 1000 minus 0.002 times 100 to the cube, 2000. So minus 2000, then 0.144 times 100 to the square, 1440. You do that, so you're going to say minus 2000, plus 1440 meters. So the displacement of the particle from O is 440 meters when t is 100. Question is taken from October 2015, A-Level Maths, HSC M1.